here is another method, and this is for advanced students. So, especially further math students who are doing or who are in SS1 or 2. So, we can use geometric progression. So, sum to infinity. We can use it to find, we can use it to convert decimals, unending decimals to fractions. Let's see that. If we have the 0.4444 till Jesus comes. So solution number one, 0.444 and so on. What are we going to do? We can rewrite this in sum to infinity as fraction. So this can be written as the first 4, place it 4/10 plus the second 4 over, since we have used 10, the next one will be 100. So we have 2 because it has become 2 now. So when we get to the third one, we have 4/1000, since we have gotten to the third one. Then for the fourth one, we have 4/10,000 plus and so on till infinity. We don't know where it ends. So according to sum of GP, if we are taking the sum of this, so according to geometric progression or sequence and series generally, this first one is taken as our first term. This is the first term. This is the second term. This is the third term, and so on. And this is the fourth term, and so on. Now, the first term is taken as A T1 or A is the first term. Now, the second term is T2, the third term is T3, the fourth term is T4, and so on. Now, for GP, we need common ratio. There is a common ratio between all these numbers that they added together. What do we mean by common ratio? They have multiplied this by something to get this. They have multiplied this by something, the same thing, to get the next one. They multiply this by the same thing again to get, that's what we call common ratio. Now, how do we find common ratio in geometric progression? In geometric progression, if we divide the second term by the first term, we get the second term, we will get the common ratio. That is, common ratio R is equal to T2 divided by T1, or T3 divided by T2, or T4 divided by T3. So what is T2? T2 is 4/100 divided by T1, which is 4/10. Now, this can give us 4/100. Let's change it to multiplication, all over 10/4. 10 year 1, 10 year 10, 4 year 1, 4 year 1. So the result is 1/10. That means 1/10 is the common ratio, the number that they are using to multiply to get each term. Now, the formula for sum to infinity, that's S sub infinity equal to A all over 1 minus R. So if we use this, this will give us our result. Let me clear the top so that we can have space. So using the formula, S sub infinity equal to A all over 1 minus R. Our first term is 4/10. So I'll put it 4/10 divided by 1 minus, what is our common ratio? Common ratio is 1/10 from what we have calculated. So from here, I will simplify. Then that will give me my final answer. So 4/10 divided by 1 minus 1/10. If you are subtracting fractions from 10, you don't need to stress yourself. Just say, if you are subtracting fraction from 1, you don't need to stress yourself. Just say 10 minus 1. That will give me 9 on top. 9 divided by 10. So from here, 10 and 10 can cancel out. 10 can cancel 10. So we have 4/9, which is the same answer as what we got in the previous methods that we have used. So that's very easy. You can follow the same pattern to do question 2. But let me do question 3, because that one is quite different. I can divide the board into 2. So let's have 0.12, 12, 12, and so on. Now, What I will do, I will write this as sum to infinity. I will write it as sum of fractions. This is the repeating digits are 1, 2. So that's 1, 2 all over. How many numbers? So I'll put hundreds. I'll put 0, 2 zeros because I have two numbers repeating. Plus the second 12. This will no longer be over 100. We will count how many digits do we have now that we are at the second 12. 1, 2, 3, 4. That means I'll put 1 and put 4 zeros at the back. Plus the third one is 12 all over. How many digits do we have now? We have 6 digits. Write 1 and put 6 zeros. So plus and so on. So we can take the sum to infinity. We don't know the end. So that means this will be my first term. Don't forget the formula. The formula is S sub infinity equal to A all over 1 minus R. Let me first find my first term. My first term is A, which is 12 all over 100. Then my common ratio is second term divided by first term, which is 12 all over 10,000 divided by 12 all over 100. So we can rewrite this in fraction. We can rewrite this, turn this to multiplication. R will be equal to 12 all over 10,000 times 100 all over 12. 12 here 1, 12 here 1. 0, 2 zeros cancel 2 zeros. So we will have 1 all over 100 as our common ratio. So from there, I will substitute this in the formula. So sum to infinity equal to A is 12 all over 100 divided by 1 minus R is 1 all over 100. So don't bother yourself if you are subtracting anything from a fraction from 1. Just f to the infinity equal to 12 all over 100 divided by, so just say 100 minus 1. That's 99. So 99 all over this 100 again. Since we are subtracting it from 1. Now don't disturb yourself, don't waste time. 100 can cancel 100. So S to infinity equal to 12 all over 99. So we can reduce this to 3 here 4, 3 here 33. So that's 4 all over 33. That's my final answer, which is the same answer as what we got in the previous example. Thank you for viewing this. God bless you.